We're going to continue your inequalities education with a look at OR inequalities. There's also a thing called AND inequalities, but they're not going to be covered on this video. And it's a little bit unusual because now instead of having one inequality to work with, you have two. You can think of these as two different equations, but I'm not supposed to use the word equation because equation would have an equal sign and we have inequality signs. So anyway, pretend there's an inequality here and you beep, 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 beep. You do all your work and you come to your final result. There's another one here, beep, 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 beep. You come to your final result. Well, so you have two final results and you're going to graph both of those. So I would say, hey, x is greater than or equal to 3, closed circle, and shade to the greater. X is less than negative 2. This is a less than, so I will do a open circle because there's no bar underneath there. I didn't have one of those. And since it's less, I shade to the left. And so now what this is saying is any number along this span or this span would work in either this one or this one. Any number in here is in no man's land. It's not going to work for either of those. We'll show you that here when we work through this problem. So, by the way, this rule still applies. Anytime you're in the world of inequalities, that rule applies. So what I'm going to do is I'm going to take this example. We're going to work through it and then we're going to graph it. You have two different inequalities here. And it would probably be a very good idea for you to pause the video, work out both of those, and see if you match my answer. If you don't do that, then you're just going to look at what I do and say, well, yeah, he must be right. And that's not a very good practice in math. So go ahead and pause, work it out. And hopefully you did pause and work it out, but I guess only you know that. I'm going to reveal my work. On this left-hand problem, inequality, you should notice that you had to divide by a -3, so you had to flip that inequality sign, because remember that rule is universal in inequalities. On the one on the right, you never had to flip that inequality because you never multiplied or divided by a negative. So as I look at this, I say, okay, my answer is x greater than 4, or x less than or equal to 2. That means if I select a number from the shaded region, it's going to work in one or the other of those two inequalities. If I select one from dead man's land, like 3 is in no man's land, then it shouldn't work in either one of those. So instead of testing one that I think would work, I'm going to test x equals 3. I'm going to pause it while I put that work down, and then we'll be back. Okay, I'm back. I chose a number from no man's land, and I'm plugging it into here and here. When I plug it into here, it works out where I get a -8 is less than -11. But we know -8 is not less than -11. Remember that in the land of negatives, your brain can sometimes deceive you. This is not a true statement, so it didn't work. But remember, we selected something from no man's land. It should not work in either one of those. And when I plug it into this one, it also doesn't work. So 3 doesn't work in either one. That's why I know that that's a good sign. If I selected, say, a 6, that's from the shaded region, it's going to work in one or the other. If I selected a 0, it's going to work in one or the other. So not a lot new here other than you're graphing both of them, and you have this unusual thing where you're given two inequalities instead of one. See ya.